Picture one bug. Inside require role from video 10, someone flips a comparison from greater than or equal to less than or equal. Suddenly a viewer's rank, checked against the editor bar, evaluates as sufficient when it shouldn't. Every action in this app that calls require role, creating tasks, assigning them, editing a project, is now silently granting access it was supposed to deny. That's not a bug in one feature. It's every permission check in the entire application, wrong at once, from a single flipped operator. And nothing in Video 14's tests would catch it, because those tests mock require role entirely. They assume it works. Nothing has ever actually verified that it does. That's the gap today closes. Require role is the single function every server action in TaskRaster leans on to decide who's allowed to do what. It's disproportionately high stakes for how short it is, which means it deserves the most exhaustive test coverage of anything in this codebase. Every role, every membership state, tested directly against every combination that matters. Let's get into it. Why this function gets special treatment. One function, every security boundary. Video 14 tested create project by mocking the things around it. Require role is different. It doesn't have much around it to mock. It's a short, self-contained function that reads a project's owner and a membership row, then does one comparison. That's exactly the profile of a function where a one-character bug is both easy to introduce and catastrophic to miss. The right level of coverage here isn't a couple of representative cases. It's every meaningfully different combination of role and relationship to the project, tested explicitly, so nothing is left to probably fine. Testing the owner path. Step 1. Owner access bypasses role entirely. Lib permissions.test.ts. Import. Describe, it, expect, vi, before each from Vitest. Import require role from .permissions. Import Prisma from @ts Prisma. Vi mock @ts Prisma. Prisma, project find unique VIFN, project member find unique VIFN. Before each, clear all mocks. It grants access to the project owner regardless of min role. Async ICO, VI mocked Prisma.project.find unique, mock resolved value, user ID owner 1, as any. Const result is await require role, owner 1, proj 1, owner, expect result to be true. Expect Prisma.projectMember.findUnique not to have been called. That last assertion is doing real work. It proves the function short circuits on ownership and never even queries project member for the owner's own project. That's not just a performance detail. It's confirmation that two access paths from Video 10 are wired the way the design intended, not just happening to produce the right answer. Testing member roles with table-driven tests. Step 2. Every role against every bar. Testing owner, editor, and viewer against every possible min role one at a time would mean 9 nearly identical test blocks. Vitest test each turns that into one table and one test body, which is both less code and harder to accidentally get wrong by copy-pasting a stale expectation into the wrong block. Test each. Owner, viewer, true. Owner, owner, true. Editor, viewer, true. Editor, owner, false. Viewer, viewer, true. Viewer, editor, false. Viewer, owner, false. Member with role versus min role, async. Member role, min role, expected. vi.mocked prisma.project.findUnique, mock resolved value acts, someone else as any. vi.mocked prisma.project.member.findUnique, mock resolved value as any. Const result is await require role member 1, proj 1, min role as any. Expect result to be expected. 9 rows, 9 assertions, 1 test body. This is the table that would have caught the flipped comparison bug from the cold open immediately. Editor against owner expecting false is exactly the row A not equal to A typo breaks, and it's sitting right there in the table instead of buried in a case nobody thought to write by hand. Testing the edge cases. Step 3. Non-members and unexpected data. It denies access to someone with no membership row at all. Async. Vi mocked prisma.project.findUnique, mock resolved value as someone else as any. Vi mocked prisma.projectMember.findUnique, mock resolved value null. Const result is await require role stranger 1, proj 1 viewer. Expect result to be false. It denies access when the project itself does not exist. Async. Vi mocked prisma.project.findUnique, mock resolved value null. Vi mocked prisma.projectMember.findUnique, mock resolved value null. Const result is await require role user 1 ghost proj viewer.
Expect result to be false. The second case is the one people tend to skip. A deleted or mistyped project ID shouldn't throw an unhandled error, or worse, quietly default to true. Denying by default when the project can't even be found is the safe failure mode, and now it's a permanent enforced fact about this function, instead of an assumption. Note: defensive tests like these two rarely reflect a bug you've actually seen happen. They exist to lock down what should happen in a state nobody's hit yet. That's a cheap insurance policy on a function this central. A few extra lines now, against a category of bug that's expensive to discover in production. Recap and call to action. Require role is now tested against every role, every relationship to a project, and the edge cases most people forget. 9 table-driven cases, plus the owner short circuit plus 2 defensive checks, all running in well under a second. This is the highest value test file in Taskmaster. Short function, enormous blast radius, now fully pinned down. Everything up to this video has tested code in isolation, with Prisma mocked out entirely. In video 16, we stop pretending and test against a real database, catching the category of bug that only exists at the boundary between your code and Postgres.